Okay, so let's go over the test. This is the test from March 13, 2019. So here they want you to to basically make a single trig function. So you need to fold here secant x times 1 is just secant x, and this is going to be secant x sine x plus tangent x, and then this is going to be minus tangent x sine x, right? So 1 over cosine is secant minus 1 over cosine times sine x plus I'm going to leave this as tangent, and this is going to be sine over cosine. That's tangent, right? Well, this is sine x, so this is going to be 1 over cosine x minus sine x over cosine x, which is tangent. This is tangent also, and this is going to be sine squared x over cosine x. Okay, so this cancels. So I have the same denominator here and here. I'm gonna make it into one single denominator. This is cosine x, 1 minus sine squared x. This is a Pythagorean identity. This turns to be cosine squared x over cosine x. So this is gonna be cosine x, right? And that's it. You make it into a single trig function, right? Next, I will do if you notice, this is cotangent, and I have tangent on the left side. I'm going to work with the left side. So this is 1 over cotangent x. I'm going to leave secant as it is, and I'm going to multiply secant by cotangent x, top and bottom. So I have the same denominator now, cotangent x, and I have on the top, I have on the, or in the numerator, I have 1 plus secant x cotangent x. So this is the same as 1 plus 1 over cosine x cosine x over sine x, and then this is going to be cotangent x. So this cancels, and you get 1 plus 1 over sine x over cotangent x. So this is going to be cosecant x for this part, right? That's cosecant, and then this is going to be plus 1 cotangent x. Done, right? That's what they want. Next. So I'm gonna use the sum and difference formula. Sine x plus y equals sine x cosine y plus cosine x sine y, and 17 pi over 12 I can write as 2 pi over 12 plus 15 pi over 12. This simplifies to pi over 6, and this is 5 times 3, 4 times 3 cancels out. So this is sine pi over 6 plus 5 pi over 4, and you know how to do that, right? I mean, that's not difficult at all. So this is same thing, right? Sine pi over 6 cosine 5 pi over 4, and then this is going to be plus cosine pi over 6 sine 5 pi over 4. Now you just replace those values, right? Whatever they are. So that's going to be sine, that's going to be 1/2. This is root 2 over 2, and it's going to be in the third quadrant, right? And this is square root 3 over 2, and this is root 2 over 2, but it's also negative because we're in the third quadrant. So this is going to be negative 2 over 4, and this is going to be negative root 6 over 4. So the answer should be negative root 2 minus root 6 over 4. And notice that in B, they give me the same numbers. So I'm going to use the same numbers, but different formula, all right? So this is cosine x plus y. This is cosine x cosine y minus sine x sine y. So let's see. Now I need to plug those the same numbers, right? Cosine pi over 6 plus 5 pi over 4. So this is cosine pi over 6 cosine 5 pi over 4, right? And then minus sine pi over 6 cosine 5 pi over 4. This was sine, by the way, sorry. And now we just compute, right? Cosine pi over 6 is the same as root 3 over 2. This is root 2 over 2. It's negative again. This is minus sine pi over 6 is 1/2. And this multiplies by negative root 2 over 2. So this is going to be positive this time. So it's going to be plus root 2 over 4. And here we have negative root 6 over 4. So if you want to write a positive first and then negative after, then that's fine. Okay, so that's the answer for that problem. Very easy. Next, this thing. I need to expand here. Okay, I'm gonna work with this side. So again, I'm gonna copy the formula. I don't want to write this again. Okay, so this is that formula. Okay, copy. Let's see. So I have sine x plus y is the same as this, right? So that's the expansion for the first one. The first one is this one, if you don't know. This is the first one. Okay, and then minus, I have to do the same thing, but with different sign, right? Same thing with different sign. Same thing with different sign. So this is gonna be minus this time, right? So now, same thing. And now I'm gonna change the sign. So this is gonna be sine x cosine y plus cosine x sine y. Actually, this is minus, I'm sorry. And cosine x sine y. So these, they cancel because they're opposite, right? And then this is gonna be 2 cosine x sine y. Done. Okay, and that's what you need to prove on the left side. So that's done. Next. So this is very straightforward. Again, this is just a coterminal angle. So I'm gonna work 13 pi over 6 minus 12 pi over 6. This guy represents 2 pi, okay? So that's gonna be pi over 6. Therefore, you can say sine this thing is the same as sine pi over 6. You know what sine pi over 6 is. So that's gonna be 1/2. Done, right? Next one, you have to use the even function, right? Cosine is an even function. So this is gonna be cosine pi over 6, right? So cosine pi over 6 is root 3 over 2. That's it. Next, tangent. So tangent, I'm gonna use, well, they give me in this part 25 pi over 4. So I'm gonna subtract 24 pi over 4, which is like 6 pi, or going around the circle 3 times, the unit circle, right? So that's gonna be pi over 4. So if you do that, then tangent 25 pi over 4, it's coterminal with tangent pi over 4, and tangent pi over 4 is just 1, right? Just in case you don't know what's an even and odd function, an even and odd function means even is with respect to the function has to be a mirror image with respect to the y-axis. What do I mean by that? That's like, for example, for cosine, you know that if the bounds are from 81 to 1, the period usually is 2 pi, and here we have in the parent function, right? That period is 2 pi. So this is 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and 2 pi here, right? So this is negative 2 pi. And if you draw the function, it should look something like this, right? Cosine of 0 is 1, here, 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 and here. That should be the behavior of a function. And you have here, 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 and here. So you know how the function look like. So it looks something like this, right? It looks something like this. Okay. So if you think about it, this part, right? And if you fold the right part or the green part to the orange part, it's exactly the same image, right? So that's the reason it's an even function, okay? Because when you sort of folded the green part to the orange part, it's gonna be exactly the same graph with respect to the y-axis. So an even function is always symmetric with respect to the y-axis, okay? So I think that's straightforward, okay? This thing. right here. So here you have, they're asking you which statement is true. You know that this is not true, this one right here. So it should be 1 and 3, right? So that should be C. This is odd, this is odd, and this is even function, okay? So just keep that in mind. So that means what? So that means that sine negative x, it's negative sine x, right? Cosine negative x is just cosine x because it's even, right? And tangent negative x is negative tangent x. Okay, so you have to keep that in mind. Okay, so this is odd, even, odd, right? Okay, that's it. Next. Okay, this one. Okay, let's see. So here we have this situation, right? So they give us negative 101 pi over 2. So negative 101 pi over 2. And they say, what's the value of negative 105 pi over 2? So if you subtract negative 4 pi over 2, that's going to be the same as negative 105 pi over 2, right? I'm going to add and then subtract, right? So that means that I can use the sine formula, right? Sine x plus y equals sine x cosine y plus cosine x sine y. You should know how to do that. Now just plug the formula, right? Sine negative 101, right? Pi over 2 plus negative 4 pi over 2, which is the same as negative 2 pi. And just use a formula, right? That's going to be sine negative 101 pi over 2, then cosine negative 2 pi plus cosine negative 101 pi over 2, and then this is going to be sine negative 2 pi. So you know what this value is, sine negative 101 over 2, it's just negative 1. Cosine of negative 2 pi, that's the even function. Again, this is the same as cosine 2 pi. You know cosine 2 pi is value is 1. And here, I don't know what this value is, but I know what this value is. This is an odd function, so the negative comes out. And I have basically sine 2 pi. If you recall what sine 2 pi is the same as 0. So that means that this term vanishes entirely. And what you have is negative 1 times 1, which is negative 1. That's it. So this is going to take some time, right? This is going to take some time. Okay. So we need to find the x-intercepts, right? And what do you want? The asymptotes and all this stuff. So the amplitude equals 3 here is the absolute value of 3. I can rewrite this as 3 sine 2, let me put that in bracket, 2x plus pi over 4, right? And I can say now that this is in that form that we want, sine x, a sine bx plus c plus d, right? And now here I can say the phase shift, right? The phase shift is negative pi over 4 units, right? To the left, what else I need to say? The period is 2 pi over b, 2 pi over 2 in this case, so the period is pi. So notice that this guy is what? Compression, right? Horizontal compression, and this guy is a vertical stretch. So that means I need to graph this thing, right? So this is going to be negative pi over 4. That's the phase shift. And the one period will be from negative pi over 4 plus pi, which is the same as 4 pi over 4. So that's going to be 3 pi over 4. So that's about here somewhere. And half of that will be pi over 4. And between these two, it will be pi over 2, right? And between these two, it's just 0. I'm going to move this line a little bit. Okay, so it may be kind of more symmetric. Okay, and well, that's one period, right? So, and the bounds are, remember, that stretch. So this is 3, negative 3 vertically. And what else I need to find? So that was one period, right? So now I need to find another period because they want 2 periods here. So 3 pi over 4 plus 4 pi over 4, which is the same as 7 pi over 4. So that will be the second period. So I see the pattern here: negative pi over 4, 0 pi over 4, or 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4. Then the next one should be 2 pi or 4 pi over 4, right? Actually pi. 4 pi over 4, 5 pi over 4, 6 pi over 4, which is going to be 3 pi over 2, 7 pi over 4, right? And 8 pi over 4 will be 2 pi, right? 8 pi over 4 is 2 pi. So somewhere around here. Let me fix this line a little bit. Okay. Okay. So that's what we have so far. Okay. So these are the 2 periods, and I need to graph this thing, right? So sine starts at 0. So it's here, 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 and I think it finished here, right? Because that's just one period. Yeah, that's it. I don't need this value. Okay, so let's join these points, or let's trace it. Let me put that in another column. Okay. Okay, so if you do that, you get this graph. Okay. Yeah. Now, so the what else we need to find out? We need to find out. Okay, so they want the x-intercepts, right? So x-intercepts. The x-intercept, we can do, let's see. Okay, so if you recall, right, the sine function, right? I mean, I can see clearly what it is here. That's gonna be just pi over 4 times n. So that would be one way to do it, but to make sure that I'm not doing this wrong, let's do, because you know that the sine function is the original one, not this one. It's 2 pi, pi over 2, and 3 pi over 2, right? The parent function. So it goes from 1 to -1, right? So when you're doing that, your bounds goes from well, sine of 0 is 0, right? It will be here, and you go here, right? Sine here, here, and here. So that's the original graph, right? So the original graphs, you have the x-intercepts. Yeah, this is 2 pi, pi. So at pi and at 0, right? At 0, and you have at 3 pi over 2. So you can say 2x. Yeah, your x-intercepts are at pi, and okay, so 2x plus pi over 2 equals pi. Okay, so we need to solve for this, right? So this is negative pi over 2 on both sides. So this cancels out. So we get 2x equals, we can write this as 2 pi over 2 minus pi over 2, which is going to be pi over 2, right? And this is 2x equals that. So you multiply by 1/2, and you get pi over 4, right? So this is one asymptote, and then you need to add the period, right? So the period is pi units, so it will be pi m, or m pi, right? Let me put m pi better. So m pi. So this is one x-intercept. So this will be pi over 4 plus m pi. So that will be one x-intercept. If you put 1 here, you can see the pattern after that. And let's see what other thing we have to do here. Let's see. Let me see, just in case I'm doing this, the x-intercept. Okay, so I have already one. So the other one, okay, so let's see what's going on. So that's the first one. And then you need to set up another one, right? You need to set up another one. Let me fix this. I'm gonna keep that. That's right, the one that I just found. And let's see another one. Okay. In the original, it should be 0, right? Yeah, because yeah, it should be the other one should be 0. So 2x plus pi over 2 equals to 0, and 2x equals negative pi over 2. Then and we multiply by 1/2. So x equals negative pi over 4. And let's see. This is right. This is pi, 3 pi over 2, 2 pi, pi over 2. Angle 0, 0, 1. Yeah, 1 is at pi. Yeah. So then the other one is a negative pi over 4. Negative pi over 4 plus m pi, and this is 0. Okay, so those are the x-intercepts for this problem. That's what you need to do. Okay, just in case. Okay, that's it. Okay. Okay, next. Okay. There's no asymptotes here for this one. Okay, there's no asymptotes. This one. This one is secant, right? Secant, you have to graph cosine first, right? Cosine x over 2. So then you graph it, right? You just need to see what's going on. So you can just say that this is 1/2 x, right? 1/2 x, and you can see that this is a horizontal stretch, right, from here. And then you can see that this is also a vertical compression, right? So this is going to bound from 1/2 to negative 1/2. There's no phase shift here, right? No phase shift. Let's see. The period, the amplitude is 1/2, right? The period equals 2 pi over b. In this case, 2 pi over 1/2. So this is going to be 4 pi. So this is, like I said before, this is a stretch, horizontal stretch. So that's going to be 4 pi. So that means this is 4 pi, this is 2 pi, this is pi, right? This is 3 pi, and so on. So two periods should be 8 pi, 6 pi, 5 pi, 7 pi, right? And we have everything so far, right? Let me fix this a little bit. So 8 pi, about that. 7 pi. So this is 6 pi. Okay. Okay, so now what I need to do is I need to do the bounds, right? Okay, now phase shift. This is cosine. So cosine starts at 1. It goes here, it goes here, then goes here, then goes here. That's one period. And then the second period will be here, 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 and here. Yes. So now we trace it, right? Sorry, we trace it, and it's gonna look like this, right? So that's the two periods, right? Now the question is, what they want me to find? What? Well, I found the amplitude. I found the period. There was no phase shift here. What else I need to find? The x-intercepts and the asymptotes, right? Oh, and I didn't draft cosecant yet. So this is what? Cosine. The asymptotes are here at pi, 3 pi, right? 5 pi, and 7 pi, basically whatever the value, the function touches the x-axis, right? So I have my functions here, and now I need to find out, basically, and you can graph this thing, by the way, before I forget. So this is cosecant, right? Cosecant goes like this, cosecant goes like this, and then it should be something here about that. So now what I need to do is I need to find out the asymptotes here, right? Where they are, right? All asymptotes, not just one. So what I can do is I think about my original function, right? So I think about cosine, right? So cosine is, we know it's 2 pi, pi over 2, and 3 pi over 2, right? So let me move this around a little bit. So this is 3 pi over 2, and actually 2 pi, sorry, 2 pi, and this is 3 pi over 2. And you know the bounds are between 1 and 81. So this is gonna, go up and down, go up and down. So I'm sorry about that. So that's gonna be, so cosine is 0. Cosine of 0 is 1. It's gonna go here, 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 here. We know that, right? So this is the graph, basically, right? This is the graph. So now that means that if I set the parentheses equal to pi over 2 and 3 pi over 2, then I can find the pattern for this, for the asymptotes. So x over 2 equals pi over 2. So you multiply by 2 both sides, and you get x equals pi. Therefore, one asymptote is at pi plus 4 pi, because you add the period here. So this is one asymptote, okay? And then the other asymptote will be at, because this reflects one period, right? So then after that you can say, oh, 4 pi m, by the way, I forgot the m. And then you have to do for the second one, you set it, the parentheses equal to the other asymptote that should be at. So x over 2 equals 3 pi over 2. So you multiply by 2 both sides, and you get x equals 3 pi. So that means x2 equals 3 pi plus 4 pi n. So that will be the other asymptote, okay? So the other asymptote will be at here, okay? So you have the two asymptotes, okay? So that's what happens here in this problem, okay? Okay. So the asymptotes they should be there. If you plug, think about it. If you plug 0 in the first one, you get just pi. If you plug 1, you get 5 pi, right? If you plug 2, you get 9 pi. Okay, and for this one, if you plug 0, you get 3 pi. If you plug 1, you get 7 pi. So that makes sense. Okay, so that's the answer for this thing. Okay. Okay, next graph. This is taking a little time because it's hard for me to just do it. Right. Okay, so that's that thing. Okay, next. Okay, this one is sine pi over 4. So, well, this is already set up for me, right? So the only thing I need to find out is the phase, well, the amplitude is going to be a vertical stretch, right? So this is 6, and the phase shift is going to be just pi over 4 units, right, to the right. And what else I need to find out? I need to find out the period. The period for tangent is pi, not 2 pi, pi over 1 in this case, right, or just pi. So that's the period. And then what else I need to find out? Now I can graph this, right? So if I graph it, just remember that now you are at pi over 4 to the right. So this is pi over 4 units. So my first point starts here at pi over 4, right? That's my first point. And then what I need to do is, remember this is from 6 to -6. And I need to find out what's one period of that, right? But I need 2 periods. So this is going to be pi over 4 plus 1 period is 4 pi over 4. So that 1 period is going to be 5 pi over 4. So 1 period is here, so it's going to be 5 pi over 4, okay? And then that means that between these two is 3 pi over 4, and between those two is pi over 2, right? Or 2 pi over 4. Let's put 2 pi over 4 to make it simple. And then this is 4 pi over 4, and then we change it. Then this means that this 5 pi over 4 is 1 period, and you need 2 periods. So that's going to be 4 pi over 4, which is going to be 9 pi over 4. So that's going to be 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, and so on and so on and so on, right? So 9 pi over 4 should be here. So now be careful, right? Now I need to find the asymptotes, right? So in order for me to find the first asymptote, remember, this is a translation. So to find the first asymptote, I need to set it up equals to pi over 2. So I need to solve for this. So I need to add pi over 4 in both sides, right? So if you do this, you get x equals pi over 2 plus pi over 4. You need to find common denominator. So that's going to be 4 multiplied by 2 and 2. So that's going to be 2 pi over 4 plus pi over 4. That's going to be 3 pi over 4, right? So that's going to be the first part, right? So that's the first asymptote. So the first asymptote is here at 3 pi over, right? And the other one should be somewhere. Let's find out where it is. So the second asymptote, I set up the parentheses equal to pi over negative pi over 2, right? Because that's where the other asymptote for tangent is located. So I need to compute that. So that's going to be pi over 4, pi over 4. So these cancel. So you get x equals negative pi over 2 plus pi over 4 multiplied by 2, right? And then you get negative 2 pi over 4 plus pi over 4. Let me see if that's right. Yeah, that's right. So I add pi over 4. I get times 2. That's 4 times 2, and that's going to be negative pi over 4. So the other asymptote is going to be a negative pi over 4. So that means that that's around here somewhere. So the asymptote is somewhere around here, right? So now, yeah. So let me make it more even. Let me see if I can move this around a little bit. Make it more symmetric or something like that. Yeah, like that. Okay. So that's the best I can do for now. So yeah. So yeah, it should be a little bit more here, this one. Okay, let me erase this stuff. But we know that the asymptote is there, right? Negative pi over 4. So negative pi over 4 should be a little closer to that. So negative pi over 4 is here, right? And we do the asymptote, okay? And if you want to find the next asymptote, from 3 pi over 4, you need to add 3 pi over 4, you need to add the period, which is pi, which is 4 pi over 4. So that's going to be 7 pi over 4, right? So if you do that, that's the next asymptote, 7 pi over 4. Okay. Now you need to find that you know how the graph look like, right? So the graph look like something like this. This is -6. So at 0, the graph, you can just plug the numbers, right? If you plug 0 here, you get negative tangent pi over 4. So that should be -6, right? So that should be around here. And then at pi over 4, that's tangent of 0, right? Yeah, so pi over 4, that's 0, tangent of 0, it's 0, right? And then if you plug pi over 2, you get pi over 4, and you know that's 1, but because it's a stretch, it's going to be a 6. So this is the behavior of the graph, something like this. Okay, so the same thing applies here, right? So it's 0, 1, 2, right? So it's the second one. So here will be this point will be here, this point will be here as well, and then this is the behavior of the graph. Okay, and then for the They want you to do 2 periods, right? So we did 5 pi over 4, 9 pi over 4. So if we do one more, let's do that. Let me put that here. So the next one should be at 10 pi over 4, right? And let's find out what the next asymptote will be. So 7 pi over 4 plus a period is 4 pi over 4, right? So that's gonna be, yeah, right? 7 pi over 4 plus 4 pi is 11 pi over 4. So I need to do a little bit more. So I'm gonna try to squeeze them a little bit more. So 9 pi over 4, 10 pi over 4, 10 pi over 4, and 11 pi over 4. It should be around here somewhere. Okay, you get the point. So this is here. And now you graph it, right? Same thing. Here, here, and here. And you get the picture of this thing. Okay. Okay. So that's the graph, right? So now they want you to find out, yeah, if they want you to find out the intercepts and all that stuff, you have to do this thing, right? Let me erase this stuff. Let's see. Okay. Sorry about that. Okay. So if you want to find out the asymptotes, so you said x minus pi over 4 equals pi over 2. So we solve for that. This is pi over 2 plus pi over 4. So this is gonna be, remember one period is from pi over 4 to, I forgot what was it, pi over 4 plus 4 pi over 4. So 5 pi over 4 is one period, right? So yeah. So from here to here. Yeah, that's one period. Okay. So yeah, if we solve for this, we get 3 pi over 4, right? Multiply by 2, 2. Yeah, that's 3 pi over 4. So this is going to be 3 pi over 4, the asymptote, right? Asymptote, well, the asymptote is going to be at 3 pi over 4 plus a period and n, right? And then the next asymptote is going to be at x minus pi over 4 equals negative pi over 2. Add pi over 4 in both sides, negative pi over 2 plus pi over 4. So you multiply by 2 here, and you get the next one, right? Or you can use 3 pi over another asymptote if you want, doesn't matter. So this is going to be 2 pi over 4 plus pi over 4. So that's going to be negative pi over 4. So the other one can be a negative pi over 4 plus pi n, right? And that's it. That's the asymptotes. Okay. Okay, so this took a lot of time because this I have to draw it and explain it. Okay, so this one, right? So this one is easier. So cosine inverse of 1/2, right? So you have to think, they give you this value and you need to find out the angle, right? So 1/2, you should know what is cosine inverse. Remember, for inverse, cosine is from 0 to pi, right? So they're asking you for 1/2, so you should know what is that, right? Cosine 1/2 is pi over 3, right? That's it. This one, cosine of 0, where is that work? So cosine is the same, this is the same for both, right? That restriction, right? And cosine of 0 is just at pi over 2, right? Okay. Okay, so let's continue. Then this one, same thing, right? So in this case, they're asking you for, you know, the cosine inverse is from 0 to pi. So you know you are in the, not in the first quadrant, you're in the second quadrant. So this is going to be 3 pi over 4. That's it, right? I mean, that's just straightforward. And this one, right? Okay. They want you to find the exact value of this thing, right? So sine inverse -1/3. Okay. So basically you need to find where this happens, right? So sine is from -pi/2 to pi/2, right? That's the restriction. And they're asking you for 1/3, right? That we don't have, right? Because usually we have 1/2 and square root of 3/2, or we have a √2/2, right? We don't have that 1/3 thing. So, but anyway, we know that we're in the first or the fourth quadrant, right? Because pi/2 is here and pi/2 is here, right? So we know what's going on. In order to be negative, then in the first quadrant is positive, everything. So we're in the fourth quadrant, okay? So that means that, you know, sine is y/r, right? So r is 3, it has to be positive, and this is -1. So that means that I need to find out this number, right? So that's going to be probably 9, what is that thing? 8, square root of 8, 2√2, right? I think that's what it is. Okay. If you don't know how to do it, or you don't know what I did, you can use Pythagorean theorem, right? A squared plus b squared equals c squared. You have the hypotenuse, you have the y, right? So that's -1 to the second power, a squared. So this is a squared plus 1 equals 9, a squared equals 8, right? Subtracting 81 in both sides. Take the square root, a equals plus or minus. This is 4 times 2, so this is 2√2. But since we're in the first, in the last quadrant, this is going to be positive. So you found already what's that thing, right? Now you need to find out what's cosine of basically of this thing, right? So cosine of this angle, this represents an angle now. Cosine of that angle. So what is cosine of this thing, right? Cosine of everything, of whatever is inside, right? So cosine of that, cosine, sine inverse. Well, we said sine inverse, it was, well, we draw the picture already, right? So cosine, sine inverse, -1/3, all this stuff equals just to cosine of this triangle. So cosine of this triangle is adjacent over hypotenuse, right? So this is 2√2/3. That's it, you're done. That's the answer. Okay, let me put that in a different color. That's the answer. Next, this thing. Below is the third quadrant of the unit circle. Okay, so this is straightforward too. So you know this is 180, this is 210, 225, right? And then this is gonna be 240, right? So in radians, so that means we are at pi/3, 2 pi/3. This one is 4 pi/3. This one is this is 7 pi/4. Actually 5 pi/4. Sorry. And this is gonna be pi/6, 5 pi/6, 7 pi/6. Yes. Okay, so now we need to find the coordinates of that, right? So we know that pi/6 is 3. So this is gonna be 3√2, 1/2, both negative, right? Then this is gonna be the reverse, right? This is gonna be 1/2 √3/2, both negative again. And this is √2/2, √2/2, and both negative. Done. That's it. That was the test. And they're asking you the angle measured in degrees. So we already found it, right? In degrees. Here, here, here. That was part A. So you can say A is 210, B is 225, C equals, well, I should put 1, right? I mean, 11A is 1, 2, 3, right? And then the other one, the angle measurement in radians. The angle measurement in radians. So 11B, it should be 7 pi/6, right? then 5 pi over 4, and then 4 pi over 3. And then what is the other one? The coordinates of the points. So I already did it, right? So everything is there. So 11C, I'm gonna put that in different color, blue, okay? So that's just this thing, negative root 3 over 2. Check your work when you're doing this, because sometimes we rush and then we might get the wrong answer, okay? So make sure that you check your work. And then this is negative 1/2, negative root 3 over 2. Done. Done. Okay, this is it. Thank you.